The demonstration kit you see before you, featuring Eaton's E58 harsh duty sensor family, will show you key performance features of this sensor important to OEM customers in a variety of industrial applications. In this video, you'll see Eaton's Senior Applications Engineer Jim Streckenbach putting the harsh duty sensor through its paces. Watch him work and think about what the words harsh duty mean to you in your machine application. If you're a customer who values remote indication of sensor status, harsh duty means an indicator LED you can see clearly from more than 500 feet away. If you're a customer who needs a sensor to burn through the steam of a car wash, or who wants to see through packaging to inspect for the presence of a product inside, harsh duty means unmatched optical power that gives the E58 enough range to see 800 feet at distance and enough power up close to see through 6 inches of solid ice. If you're a customer who needs a sensor that can see a great distance but who doesn't want to struggle with alignment, it's the E58's forgiving 6-degree beam angle, compared to competitive sensors at only 1 or 2 degrees. If you're a customer who needs to dunk or spray or wash down the sensor, it's the fact that every E58 sensor is fully tested 6 feet underwater. And finally, if you're the customer who needs a sensor resistant to cutting fluids, oils, and other chemicals, it's the 316 stainless steel, glass, and Vitron housing components, and a unique construction technique using only mechanical seals.
Hello, I'm Jim Streckenbach in the Eaton Sensor Applications Group. I'm here to demonstrate a E58 harsh duty high power through beam sensor and the equivalent in the Banner's product family, their SM30 series. First thing I'd like to just mention about is that ours uses a visible red LED as the primary source beam. The Banner units use a infrared beam. The alignment indicators, which are very useful for people when they're setting these things up and viewing them from a long distance, are quite apparent, the advantage on the E58 harsh duty series. You got the burn and ring of fire on the back here. That can be seen 2 blocks away. Banner's unit uses a little port on there with a visible red LED so you can see when it's on and off. Not very visible, it is functional, it is usable, but this one here is a lot more meaningful, especially if it's in a difficult area to view what's going on. The lenses on these units are different. In ours we use a tempered glass lens. We also have a polycarbonate hard coat one that can be used in environments where it may be necessary because of food processing type requirements where they don't want glass or something that could fall into a batch of processed food. In the Banner unit, theirs comes with a acrylic lens. We're for the standard model with a tempered glass face lens, but we do offer an option for a hard coat polycarbonate lens. Another important feature of these devices in certain applications is the response time. With our E58 harsh duty series family versions, we have a 1.6 millisecond operating response time in DC versions. On the Banner units, whether they're AC or DC versions, they are a 10 millisecond response time. Where that can be very important is that we have a lot of applications where these have been used in over-height detection systems, like Chesapeake Bay Bridge and Tunnel System, New York, the Holland Tunnel, and all over the United States, and in Europe also. Other popular applications for these sensors, since they are rated for very long sensing distances, as shooting, for example, 300-foot distances on accumulating conveyor systems, because of their high power and when they're moved closer together, they're excellent for applications in plywood mills where they're laminating the plywood boards together, and the steam and the contamination that's involved there, car, industrial bus washes, train car washes, and again, many sawmill applications out there and mining applications too. Okay, we have the through beam pair set up at a 4-foot distance. The sources are across from us. At this distance, the E58 harsh duty sensors have an excess gain or operating margin power of over 40,000 times more than it takes for them just to be able to see each other. I've got 14 sheets of paper here I'm going to use as an attenuating circumstance, let's say contamination in environment. And what I'm going to do is I'm going to put that in front of the receiver's lens here. As you see, the receiver's output is still on. Put my hand through the beam and it turns on and off, okay? I'm seeing through 14 sheets of paper here. Now I take the same thing, put it in front of the source of or the receiver on the Banner unit, and he's blocked. I have gone and carefully aligned both pairs of these, and I have a sheet here. I've got 5 sheets of paper in front of this now. You can see him turning on and off. I've got a couple more here. We add one more, and suddenly that one stops working. And you can see ours is seeing through this without a problem at all. High excess gain means reliability and dependability in applications where you've got contamination involved. Contamination on the lens, or particulate, or contamination that might be in the atmosphere between the lenses. Okay, the beam angle on our sensor is about a 6-degree beam angle, a little bit broader than the Banner's unit. What that means is that if there is motion between the pairs of sensors, like let's say again on an overheight application where they're up on big stainless poles looking across a highway, those could move independent of each other, which could move them out of alignment, which can change their excess gain signal strength and operation reliability. A broader beam pattern means better reliability if things cannot be held constant. Here's the Banner unit now. I'll move him off axis, and we'll watch until their receiver just turns off right there, okay? And I'm sitting at an angle of somewhere around 30 degrees here. Now I take our unit here. Of course, we do have a visible red source beam here, and I will move him similar. I've gone off on an axis at 60 degrees. Now I must say something too, that at this close range though, the lenses can possibly see each other a little bit, so it just means, again, that higher power means better ability to see it even as we go way off axis, and it's only seeing a sliver of the portion of the lens area from this short distance. Over longer ranges, where this kind of application really becomes your friend in aiding you in making sure that when you do align it up, it will work reliably for a long time period. Another cool advantage of having a visible red source beam is that you can use a retroreflector target to aid in the alignment process. I take a little cup and I mount it on the back of the reflector. I put it over the lens of the receiver, and then I come over here, and from my light source side, of course normally I'd be looking this way across to it, but we can move the sensor in and out of alignment, and you can easily see where the center of the beam is based on the position of sweeping it up and down X and Y.